and welcome to The Quest for AI. This is the first episode, so I'm just going to be going over the rudimentary first steps towards me creating an artificial intelligence, which are a program which can learn and a program which can also make a random but somewhat informed decision. So I've got a couple of programs here. They demonstrate these different capabilities. So actually, I'll put this one off. This is the first program I made. It's called JuiceBot, and it's because it helps you pick a drink. It simulates your decision in picking a drink. It's a bit useless, but it shows a principle. So there are several different choices. What drink you can have. As you can see, tea, water, coffee, juice. What it does. So I'll go for it. This is in Python, by the way. It's very easy language to get started on. So go for it. Import random. That just lets you deal with sort of like random numbers and generate random numbers and stuff like that. You've got waiting area, which is a list, obviously, and the reason it's called that is because you're going to be putting in, the user is going to be putting in a series of different weightings, so basically your favourability towards different drinks. It says here, so it prints to the user, the weightings you're going to be asked to enter represent your tendency towards drinking tea, water, coffee or juice, and it says, obviously, they have to add up to 100, and the thing is, so then, obviously, user, in this bit here, these 4 lines, the user inputs all their weightings, and then what it does, it uses this function, append, and that means add to the end of a list. So this list right now is empty, there's nothing in those brackets, and the thing is, it takes your weightings that you put in here, and that they equal different values by the name of tea, water, coffee and juice. And it says here, for I in range, so I is just a random letter, it just goes up by 1 every time. It says, for I in range tea, so this little bit here will happen for the amount of times, never mind, so basically it'll append a full stop to this list. However many times I will go around, which is the weighting which you put in. Hopefully that makes sense. So say if I put in 70 for tea, it'd put in 70 full stops into this list. If I put in 24, it would then put in 20 slashes and so on for the different ones. And the reason we need the randomness is because then what it does is it generates a random number between 1 here and 100. So say this is 64. Now the thing is, if I like tea more and I've put in more full stops in the list, so I've put in 70 full stops into this list out of 100, what do you think is more likely to come up? Be full stops, won't it? So this number will represent a position in the list, and obviously the choices which you're more likely to have are more likely for the random number to land on. So say it was 64, well at the 64th position, that would be a full stop. So then it would output T. And look, it says here, if the choice was a full stop, you output T. If it was a slash, you output water. If it was a hashtag, you output coffee, and so on. And I'll show you this working. Enough of me badly explaining things. There it is. So I'll just take them out. So my waiting for tea, I like tea quite a lot. So I'm putting 70. Shit. Oh, actually, oh no, that's fine. Just because I accidentally pressed enter twice. Oh, I thought my program had collapsed on me then. That was going to be pretty funny. Right, so 70. I'm waiting for water. I'm partial to a bit of water, but not a big choice for me. I really don't like coffee, so I put 3 for that. Obviously 7 left over for juice, which is accurate. I'm not a big fan of juice, but I like it more than coffee. So this will now generate a random number. It'll pick a position in the list, and it'll say like what I probably would have chosen if I wanted to make a drink. Obviously, outputs the list first, and chosen water, which is quite a likely decision. 1 in 5. I would have been quite shocked if it chose coffee, but as you can see, if I expand this list, got 70 full stops in that big list, and I've got 20 slashes, and got 3 hashtags and 7 asterisks. So obviously it's much more likely when a random position is chosen it'll be a full stop or a slash. That's not my favourite of these two programs. I'll show you my favourite. This is called Detective Bot, and it's a quote-unquote simulating a robot detective. What it is, you have to put in this cringy bit of code, cringy bit of text to even activate it. So it says, you have to type in this exactly, gasp, there's been a crime, detective bot, activate. And the thing is, this is the one that learns. So in my last program, that showed an example of a program making a choice, but this, the program actually learns. So again, import random, and I just set these 2 letters to 50 and 50, and same thing, got a list, put characters in it representing each letter, and with this one there's a 50-50 chance that if I generated a random number it'd land on full stop, so D, or slash, so S. And what they represent is so D, yeah, a full stop represents this detective refusing to solve a crime. So he says, no lol, I'm going spoons to get a drink. And I assume he'll go spoons and drink in midday or something. And the thing is, what's different about this one, I've got this variable called approval. And approval is the input after that. So then the user will import something, and there's only 2 options for this, but I will expand it in the future. It says, if approval is equals to oi dickhead, solve that crime now. So basically the user tells off the program for not solving the crime. D actually gets smaller by 25, and then it loops around again, because you've got this while loop, so it'll keep looping around. So it'll loop around again, but now there's actually less of a chance that the program will refuse, because D is smaller, so there are less full stops in the list. So it's actually like improving, which is I find that really cool. But okay, obviously there's not much chance of you sort of agreeing with the program if he refuses to solve the crime, but just for principle, I put in if approval equals, alright then mate, I'll ring Bazza and we'll make it a night on the town. So you're going to go out to Spoons and hit the town with this cheeky detective. Just got a break function there, which means the program will just end. And obviously the other option, which is represented by the slash in the list, is he prints, yo mama did it. Which this is my favourite program which I've made so far. Actually, I didn't get any help off any websites with this, so I'm quite proud of it. I just made this entirely myself, so I like that. I'll just put in the text which activates the program. So with this one, there should be a 50-50 chance that the bot solves the crime or just wants to go spoons. He's refused to solve the crime. So I'm going to call the program a dickhead and tell him to solve that crime. And now I've got to put in the original activation text. Next line. Now he's actually solved the crime, and it was my mama. I've got to admit, it was my mama. Okay, so those are a couple of principles which are shown in those two programs. And next episode, I'll probably show me sort of tidying up these programs and making them a little bit more efficient. Because if you didn't notice, they're in. Well, actually, I'll save it till next time. Alright, thanks for watching. I know I'm not very good at explaining things, but hopefully you find that as interesting as I do. See ya.